Okay, so when we're doing this here, we can, if we have a calculator, we could use a calculator, but we want to see if we can use these properties of looking for these perfect power factors to be able to undo the cube roots. So here we have cube root 8. Well, cube root 8 is a perfect cube, so that works out to be 2. The fourth root of 16 is a perfect power 4, so when we fourth root it, they undo each other, so we get 2. So cube root 3 and fourth root of 16 are in the exact same spot. Okay, they're both equal to 2. When we look at 14 divided by 5, okay, really that's negative 2.8. So at 2.8, we can find 2.8 right about there. So that's going to be negative 4.4 over 5. Sorry, 14 over 5. Looking at the cube root of negative 27 divided by 2, well, the cube root of 27, negative 27, we can do because 27 is a perfect cube. Negative for odd roots is possible. So we need to have negative 3 times negative 3 times negative 3. So that's going to be negative 3 cubed. And so working that out, we're going to end up with negative 3 over 2. Negative 3 over 2 is right about there. I'm going to write it as cube root of negative 27 over 2. And lastly, we have 2 times negative 27 over 64. This is a cube root, so we're looking for perfect cubes. Well, 27 is a perfect cube. 64 is a perfect cube. So we end up with 2 times negative 3 over 4. So the negative I can put either on top. I'm just going to put it with the top. I made that negative 27 cube root, 64 cube root. That works out to be negative 3 over 4. We can simplify that fraction, and that becomes negative 3 over 2. Okay, so we end up with the same, that's going to be in the same spot. So this is going to be, well, I'll just put an arrow there. Okay, so there's our number lines, and we can do this without a calculator by looking for perfect powers. Now, again, if we are allowed to use a calculator, go ahead and use a calculator, but we also want to have this alternative strategy without a calculator. So these ones here, we need a calculator because these are not perfect powers of 3. 20 is not a perfect power of 4. 14 is not a perfect power of 3. 14 is conspicuous because it's actually has a prime factor in there, so we know that's probably not going to be multiplied to get probably not going to be a perfect cube. 25 is a perfect square, but is not a perfect cube. So none of these are able to be resolved without a calculator because we can't work them out. Okay? We can leave them in the square root form or the cube root form, but we can't actually work them out very easily. So using a calculator, we're going to work these out. So I'm going to do the cube root. So make sure you know where your cube root button is. Okay, cube root of negative 7. I end up with negative 1.91. So negative 1.91 is right about there. There's going to be cube root of negative 7. That's where it ends up on the number line. For the fourth root of, okay, so the fourth root, I have to find my fourth root button. It's usually a little, the fourth root button usually looks like this, it has a little X in there. And so the way I put it into my calculator is 4 root 20 like that. And so my calculator, when I work that out, this does not mean 4 times 20, but this is my calculator, right? So this is what it looks like on the calculator. That gives me 2.11 for ... Okay, so that's going to give me I'm going to put it right about there. So it's going to be the 4th root of 20. Okay, so again, this is not what we would ever write down algebraically. This is what it looks like on the calculator. There's our button with the x root, and we put a 4 in front to do that. Okay, so there's the 4th root of 20. This is going to be approximately 2.11 ... Negative cube root of negative 14 over 2. When I work that out, I get negative 1.205, and that is negative 1.205 ... Okay, so that's going to be right about here. So cube root of negative 14 over 2. And lastly, I'll do this one in orange, negative cube root of 25 divided by 3. We end up with negative 0.9. Oh, this looks like it's the same color. I'm going to use purple. Okay, so it's going to be approximately equal to negative 0.9746 ... So I'm going to put that right about there. Okay, so that's going to be cube root of negative 25 divided by 3. Okay, so there we have where we can put these on number line. Now these are all decimal values that do not repeat and do not terminate. So these are irrational numbers.